Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Unwrapping by Sandra and Nala. And here are the rules. Nala got a present and she was I can't speak, I don't know why. She was allowed to unwrap it all by herself. She got a little bit too enthusiastic about it and ripped everything apart, including the colorful arrows we had planned to use for a puzzle. Maybe it's still usable? Here are the rules. We have normal 9x9 Sudoku rules apply, which means place the digits 1 through 9 in every row, column, and box exactly once each. The grid is partially covered in fog. Placing correct digits will clear the fog from surrounding cells, possibly revealing more clues. Okay, so that means this is dynamic fog of war here. Arrows have been detached from their circles. Digits along an arrow must still sum to the digit in the corresponding circle. And each arrow has its own color, and arrows of the same color belong to the circle with the matching color. No arrows of the same color overlap. Okay, so that means this cell, we see the arrow, the orange arrow here. So we do see the arrow that must be related to this cell, to this orange circle. So these digits along this arrow here must sum to what this is. So say this was 1, 2, and 4, then this would have to add up to 7 because these digits along the arrow must sum up to what the circle, the colored circle that matches the arrow, that digit must equal the sum of the digits along the arrow. And there is no attached circle, so again, this doesn't work as attachments, but you just match the colored circle with its colored arrow. And the digits along the arrow must match that circle. And we also know no arrows of the same color overlap. So you cannot have a blue arrow here or a green arrow here. It has to be just orange. So that's how arrows work. Digits separated by a white dot are consecutive. Digits separated by a black dot are in a 1-to-2 ratio. And gray dots are ambiguous and can turn out to be either functioning as white or black dots for the digits they separate. Not all possible dots are given, that is, there is no negative constraint. So for example, if this were, say, a 4 here, this would have to be 2 or 8 to make sure that this is a 1-to-2 ratio. But if this was 4 here, this could be 2, 8, 3, or 5 because the gray circle is ambiguous. So it could be a white circle, which means that these would be consecutive. So that would force this to be 3 or 5 if this was 4. Or it could be a black dot, which would mean that it has to be a 1-to-2 ratio between them. So this would be 4 with 2 or 8 again. And those are examples of how the dots work. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, we have at least 3 unique digits adding up to another digit. So that's at minimum 1, 2, 3. And this digit is in a 1-to-2 ratio with another digit. So that means it has to be specifically 6 or 8. So for the minimum would be 6 because you have 1, 2, 3 as a minimum amount for along the arrow because they're all in the same box. So it could be 6 through 9 there. 7 and 9 can never be next to a black crop key dot in normal Sudoku because if you have 7 or 9, you get 3.5 or 4.5, which aren't digits. If you double 7 and 9, you get 14 and 18, which aren't digits. That's why you can't have 7 or 9 there. But the thing is, if this were 6 here, this would have to be a 3 in this situation. Well, the problem is that doesn't work because this would have to then add up to 6, and it would be 1, 2, and 4 at minimum, which means it adds up to 7. So this can never be 6, therefore this is 8, which is only in a 1 to 2 ratio with 4. This arrow then is... this has to be 1, 2, and 5 to add up to 8 because we can't have a 4 available. So this is 1, 2, or 5 here. 1 cannot be here. It could be 2 or 5, though. This digit then is at minimum of 3. And this arrow is going to be 1, 2, 3 at least. So therefore, this arrow then adds up to 9 already for this. So this must be the minimum. So therefore, this must be 3. This is 1, 2 as a pair, and this is 3. This 1, 2 as a pair eliminates 1 and 2 here, so that's 5, which makes this 2, which makes that 1. This is 9 here. This is 1, 2 as a pair again. Oh, we have another arrow, which adds up to 9. Remaining digits of this upper right-hand box are 6, 7, and 9. Remaining digits of row 3 are 4, 6, 7, 8, 9. And 9 cannot be any of these. Okay. These two add up to 9. It cannot be 1, 8, so it could be 2, 7, 3, 6, or 4, 5. So we are guaranteed one of these digits is 4, 6, or 7. Right? Because to add up to 9, it's 2, 7, 3, 6, or 4, 5. We obviously can get either a 4, or 6, or 7 there. That with these 4, 6, 7, 8 triplets means we cannot have a 4, a 6, 7, or 8 in the rest of the box. Also, let's do how many digits are here. What are the remaining digits in row 2? We have 1, 5, 6, 7. So again, this cannot be 6 or 7 because of one of these is 4, 6, 7, and these are 4, 6, 7, and 8 only. So that's guaranteed that the rest of the box cannot contain 4, 6, 7, or 8. Therefore, this is 1, 5, which eliminates 1 and 5 in the rest of the box. So this can't be 4, 5, and it eliminates 1, 5 in the rest of the row. So now we have a 6, 7 pair in this upper central box. So that eliminates 6, 7 in the rest of the box. We are guaranteed then a 6 or 7 is missing here. And it can't be here, so it has to be here. So this has to have a 4 and it has to have an 8, which means this can't be 4 or 8, it's 9. 4 and 8 is in a 1 to 2 ratio with each other. So it has to be 4, 8, and 7. 6 does not have any relationship with 4 or 8. It's not in a 1 to 2 ratio with it, and it's not consecutive. So therefore, this must be 4, 8, 7, and 8. And 8 is in between because 8 is consecutive with 7 and is in a 1 to 2 ratio with 4. So therefore, this is 8. This cannot be 8 here. This is a 4, 7 pair. The 4, 7 pair eliminates 4 and 7 in the rest of the row and box. This can't be 7. This is 6, which eliminates 6 here. And this has to be not 2 and 7. It's 3 and 6, which forces this to be a 2 here. So that's 2. Remaining digits in row 1 are 4, 5, and 8. Well, 8 cannot be on this arrow because 8 and 2 already add up to 10, which is not a single digit. Can this ever be 5? 5 here with 4 is at minimum 11, which is not a digit. So this can't be 5. This is 1, which makes this 5. 2, 1, and 5 add up to 8. 2, 1, and 4 add up to 7. But we already have an 8 in column 7, which eliminates 8 as a possibility. So this is 7. This must be 4. That eliminates 4 from being here. So this orange adds up to 8. It's one. It can't be 1, 7 because of the 7 in the box. So it's 2, 6, or 3, 5. So we have 2, 6, or 3, 5 here. This can't be 3, so this can't be 5. This can't be 6, so this can't be 2. So this is 5 or 6 here. Interesting. If this is 6, say this was 5, then this would have to be 4 or 6. And we can't have 4 or 6 there because of 4 or 6 in the column. So this can't be 5. Therefore, this is 6. This is 2 to add up to 8. 6 can be either, cannot be 7, because 6 is consecutive with 5, though. And it's in a 1-to-2 ratio with 3. So that could be 3. These digits are consecutive. This 7 eliminates 7 here, so that's 9 and 7. Remaining digits in column 7. We have 1, 2, 4, and 5. This can't be 2 because of 2 in the box. This digit is in some relationship with this. If it's 1, it has to be 2 there, guaranteed. If it's 4, that's consecutive with 3 or 5, but it can't be 3 here. So, but this could be 5. Or it could be 2 and 8 in a 1-to-2 ratio. If it's 5, this has to be 4 or 6. Okay. Well, we don't know necessarily that there's a circle at the end of this. So we can't necessarily assume that this can't be 8. It could be a pill on the end, but it doesn't say pill, but I'm loath to basically make assumptions there. Anyways, remaining digits in column 8. We have 3, 5, 7, 8, 9. And this can't be 7 because of 7 in the box. 3 would mean this has to be 4 to be consecutive with it. 5 would have to also be 4. And 8 and 9 would have to be with each other. Okay. This is in some relationship to this. So if this were 3 or 4, so 9 cannot be here. If 9 is here, that forces this to be 8, but this would also have to be 8 because 9 can never be in next to a black crop key dot. So it would have to function as a white crop key dot. So this cannot be 9. Therefore, this is 4 or 8 here. This can no longer be 8 here, so this is 3, 5, or 9. If you had this being a 4 and this being 3 or 5, I think you have to have this be 8, right, to be in a 1-to-2 ratio. You can't have the other 3 or 5 because the other 3 or 5 would be here, right? So if you have 3 or 5 here, then 4, this would have to be 8 because it can't be in a 1-to-2 ratio with 2 anymore. So this could be 8. If this is 4, this is 3, 5. That makes a 3, 5 pair in the box. So this can't be the corresponding 3, 5 to be consecutive. So it has to be in a 1-to-2 ratio, and 2 can't be there because of 2 in the box. So that's if that's 4. If this is 8, that's 9. This can't be consecutive with 7 because we have a 7 in the box. So therefore, this has to be 4 in that relationship. So now we have a 4, 8, 4, 8 pair, which eliminates 4 in the rest of the box. So this can't be 4 anymore. Okay, so that limits what this is. This can be then 1 and 2 in a 1-to-2 in be consecutive, or 5 with 4 or 6. Remaining digits, so that in column 9, we have 1, 3, 6, and 9. Do we assume a single circle? I don't like that. Oh, this can't be 6. Um, hmm. Yeah, I really don't like that, but I mean, we might have to. Because it does say circle, right? So it's not pills, technically. I just don't really like making assumptions, anyways. If this is 5, that would force this to be 4. Well, at minimum. So it really probably isn't 5 and 5 here. Oh, and what does that? Okay, yeah, so actually that's one deduction you can make. If this is 5, that would force this to be 4. Therefore, these would add up to 9 at minimum. And this would have to be a 1 because there's no other place for 1 in that box. So then this would be at minimum. Well, this 5 would force this to be 3, which would force that to be 9. 9 would be consecutive with 8, which would be in a 1-to-2 ratio with 4. So therefore, this would add up to 5. This would already add up to 9, and that's not possible. So therefore, because of that, so we didn't make the assumption that's a single digit, even though it probably is. But this can't be 5 because that would make the pink arrow or red arrow. I'm not sure if it's red or pink. Let's say red. The red arrow would have to add up to at least 9 here, but it would add up to 5 here, which is not possible. So this cannot be 5. This is 1 and 2. To be consecutive or in 1-to ratio with it. That eliminates 1 from being here. This is a single digit, so this cannot be 9. Therefore, this is 3, which makes this 5, which makes that 9, which makes this 8. That's in a 1-to-2 ratio with 4. So therefore, this adds up to 7. So 1, 2, and 4 add up to 7 there. That means this can't be 2. That's 1 and 2 there. So no 1 here. That's a yellow cell here. No 3s here. No 5, 7, or 9s here. Well, I think so. This the yellow cannot have a 9 on it because a single digit plus another digit cannot, a 9 plus another digit cannot add up to another digit. If we have 6 here, that would force that to be 3 at minimum, which would add up to 9, but we have a 9 in that row. So this can't be 6, therefore this is 1. And we can't have 1, 8, because again, that adds up to 9, and we have a 9 in that row. So this must be 1 and 3, adding up to 4. No 1 here, no 1 here, no 4 here. This has a relationship. What are the remaining digits? 3, 5, 6, 7 in row, right. 3, 5, 6, 7 in row 7. I think we are guaranteed a 6 here, right? 7 can only be consecutive with 6 out of the remaining digits. 5 can only be consecutive with 6 out of the remaining digits. And 3 can only be in a 1-to-2 ratio with 6 as the remaining digits. So this cannot be 6 here. This 4 eliminates 4 here. So this is 7, which makes that 4. Do we have anything else? These are in some relationships. We don't know which. Remaining digits of row 8. 1, 2, 3, 7, 8, 9. So no 2 here because of 2 in the box. No 1 or 3 here because of 1 or 3 in the column. No 1, 2, or 7 here because of 1, 2, 7 in the column. No 8 here, no 9 here. So these have some relationship. We don't know which. Remaining digits. Okay, where is the 4 in row 9? Can't be here because of 4 in the box. Can't be here or here because of 4 in the column. And these are filled out, so it has to be here. So that's 4. Remaining digits of row 9. 1, 5, 6, 8, 9. Okay. This can't be 9. This can't be 5 or 8. This can't be 1. 5 eliminates 5 here. 6 has to be one of these two, so this can't be 6 in the box. Two has to be one of these two digits because it can't be here in box 2. These are filled out, can't be here because of 2 in the column. So 2 is only in a relationship with 1 and 3 out of the remaining digits. So this cannot be 7, 8, or 9. It's 2 with 1 or 3. Therefore, so this is 6 here. This can't be 1 because of 1 in the column here. So we are guaranteed a 6 somewhere in column 6 then. And these are 5, 6, 7, 8, 9. This can't be 9 because of 9 in the column. Where's 4 in column 2? It must be one of these two digits. 6 is obviously one of those 3. 2 is in a relationship with 1 or 3 here. Yeah, the obvious one, if this was a circle, would be this is 3 at least. This has to be 3, which makes this a 1-2 pair. But we don't have that confirmation. Whereas 7 in row 8, it has to be one of these 3 digits, which eliminates 7 from the rest of the box. So this can't be 7 there. Therefore, we know 7's one of these two. Remaining digits of column 3. We have 3, 5, 6, 8, 9. This can't be 3, obviously. Huh. What about these? Remaining digits of column 2. We have 1, 2, 3, 4, 6, 7, and 9. 4 and 7 can't be there. This can't be 1 or 3. So neither of these can be 9. 9 can only be consecutive with another digit, and it has to be consecutive with 8. Sorry, yeah. So therefore, this can't be, neither of these can be 9. 7 could be consecutive with 6 here. That would work. Remaining digits of column 1. We have 1, 2, 3, 5, 6, 7, 8. This can't be 7. This can't be 1 or 3. So that's interesting going that way. So if this were 6, that would guarantee this out. If this is 7, it's consecutive with 6, but that would force this to be 3 here, and then this is 3 or 7. So the problem is that would be 7, 6, and 3, and that would eliminate all possibilities for this cell. So this cannot be 7 here. If it's 6 here, that would force this to be 3 to be in a 1-to-2 ratio because it's not consecutive with 5 or 7 anymore here. So it would be 6 and 3, but that would eliminate all possibilities for that cell there. So this can't be 6. This can't be 1, because that would force both of these to be 2 in the same box, which is not allowed. And this can't be 6 anymore, because if this is 6, well, it just can't be 6. Right, because 6 is not in any relationship with 2 or 4. Okay. So this is 2 or 3. I think one of these has to be a 2 then, right? Yes, one of these has to be 2. Either this is 2, which forces this to be... No, it doesn't. It could be 4 and 3. Never mind. That is incorrect. So this could be 2, 3, and then this would have to be 6 in that case. 2, 3, and then 6. Or it's 4, 3, and then this could be 2 or 6. It just can't be, yeah. Or it's 4, 2, and then 1 or 3. So what do we have as, what specific things then do we have here? Okay. 2, 3, 6. So that's 2, 3, and 6. That's the only possibility, right? This can't be 4. Right, it can't be 4. And it can't be 2 again, because that's 2. 2, 3, 6. 4, 2, 1, and 3. Or 4, 3, 2, or 6. Ugh. Huh. Huh. That's pretty broad. So 2, 3, 6 means that would be 6. This would have to be 3. Right, because this would be a 5, 8, 9 triplet. That could work. 4, 3, 2, and 6. So if this is 2, 3, that makes a 6, 4, 7, 1, and 9. That does seem to work. 4 and 3 obviously makes this 6 and 7. So the only way that this is, say this was 3, it would have to be 4, 2, right? Not great. If this is, okay, so if this is 3, that would force this to be 6. This would be 4 and 2. So then this would be 1. And then either of these could be 6 or 9. That's not great. Wait, no, this would be 6. Okay, how? So if this was 3, This is 2, 4, 6. This would be 7. This would be 1, and that would be 9. Wait, but does that work? 3, 2, 4. That's 6. This can't be 2 or 3. This is 1. This would have to be 7, and this would be 9. Okay, yeah, that does work. Dang it. I mean, we could do assumption and made that a 3, but because 8 and 9 obviously doesn't add up to a single digit with 2 other digits. But technically we don't, well, I mean, it's kind of iffy if we do or don't know, right? Maybe I'm just making it harder than I should. I should just assume that's 3, right? I don't know. I'm not sure how I feel about that. um, hmm. Uh, hmm. Maybe I'm just making it too harder on myself by doing this. Just feels like I don't know. Hmm. Can this be 2? If okay. If this is 2, this becomes 3, 4. This then becomes 1, 7, 6, and that's 9. So, yeah, that could be 2. That's not great. Yeah, maybe I'm just overcomplicating things, but it just I don't know, it's the way I make so many bad assumptions, so I don't really want to make another one. And this kind of feels, even though it's not, I think, but it feels like it could be a bad assumption to be made. I don't know. Maybe I'm just trying to solve for too many things here. Um, hmm. Uh, well, hmm. So 2 would force this to be 4, 3, and 6. Therefore, this would be 1, 7, 6. That would be 9. Yeah, I mean, that seems fine. Hmm. Oh, if this is 9, that means none of these could be 9. So if this is 9, that means none of these are 9, which means that has to be 9. So that's 6, that's 9. Oh, that doesn't give us anything. Oh, 3 eliminates 3 here. So this is 8. Okay, that eliminates 8 in the rest of the row. Does that help us any? Not particularly. So 8's either here or one of these two, which is pretty broad. Um, yeah, since I've gone down this path, I'm like, dang it, I'm gonna see if I can keep trying to do this, which probably is not a good idea. But I mean, hey, sometimes we make, you know, Things that we shouldn't be doing. um, 2 is here, 2 is here, so 2 has to be one of these 3. That's not helpful. 3 can't be here. Yeah, I think I'm just making it too complicated. I don't think this was created to go down this path of assuming that you could have a potential pill here. So let's just not overcomplicate it. Yeah. 3, therefore that makes this a 1-2 pair, which means this can't be 1 or 3, no 1 or 3, no 1 or 3. That means this can't be 3. This is 7, this is 5. No 1 or 5 here, no 1, no 5 here. This is 6, 8, 9 as a triplet, which means this can't be 6, 8, and 9. Therefore, this must be 5, and this must be 1. So, this can't be 7 here. 3 cannot be either of these. 5 then has to be one of these 3 digits, so this cannot be 5 here. So this is 131 or 132, adding up to 5 or 6. So this cannot have a 6 here then, because 2 digits can never, with the 6, can never add up to less than 7. Okay, so if this were... Can this ever be 2 and 3? I think the answer to that is no, right? 2, 3 means this can't be 1 to... It can't be 6 anymore, because it can't have 6 in whatever digit here to add up to the same value as that. So this is 4, which means this can't be 4 here. There's no 4 here. This can't be 4, so 4 has to be here. Therefore, this is 1 or 2, adding up. So if this is 4 and 2, that's 1. If it's 4 and 3, that's 2. Either way, there's a 2 here, which means we cannot have a 2 in the rest of the box. So that can't be 2. This can't be 5 anymore. If this were 2, that would force this to be 3, and then this would be 2. If this is 1, that would be 2, which would force that to be 1, and that to be 2. So this can't be 2 anymore. This 2 eliminates 2 from being here, so it's 5, which makes that 2. So this can't be 2 here, so that's 2. This is a package. So where is this? I guess this is pink, maybe? 5 can't be here because of 5 in the row. So we have 1, 3, 6, 8, and 9 remaining in row 6. No 9 here, no 1 here because of 9 and 1 in the column. This can't be 5, this is a 3, 6 pair. These can't be 6 because there has to be a 6 in one of these 2 cells for column 6. So, where is this pink circle? It has to be here, and it must be 6. So that makes this 2, 1. 2 eliminates 2 here, so that's 4 and 3, which eliminates 3 there. So that's 2. Or sorry, this can't be 1 anymore. 3 eliminates 3 here, so it's 6 and 3. 6 eliminates 6 here, so it's 9. It can't be 6 or 9, it's 8. Yeah, anyways, these can't be 8 anymore because of 8 in the column. We have a 5, 6, and 9 triplet in box, this left central box. That eliminates 5, 6, and 9 in the rest of the box. This can't be 6 or 9 or 3, so this is 1. No 1, 3, or 6, so that's 7. This can't be 6 or 7, it's 8. We have a 3, 6, 7 quadruplet in column 4, which eliminates 3, 6, 7, sorry, 3, 6, 7, 8 quadruplet in column 4, which eliminates 3, 6, 7, 8 in the rest of the column. So this is 5, which eliminates 5 here, so this is 5 there. No 5, no 5, no 5. This 5 eliminates 5 here, so that's 8, which eliminates 8 here, so it's 5. No 8 here, no 8 here. We have a 6, 9 pair. This 3 eliminates 3 here, so that's 8. We have a 6, 9 pair in row 6, which eliminates 3 and 6 and 9 in the rest of that row. So this can't be 3, 8, or 9. It's 1. 8 eliminates 8 here, so it's 7, which makes this 9, which makes that 8. 7 eliminates 7 here, so it's 6 and 7. 6 eliminates 6 here, so it's 3 and 6. 9 eliminates 9 here, and this can't be 7, so it's 6, which eliminates 6 here, so it's 9 and 6. That leaves this digit as 3. This can't be 6 or 9, it's 7, which forces this to be 9, which means this can't be 9. That's 6, which makes this 9. The solution is correct. Amidst the chaos, Nala found another present. She violently starts to shred the wrapping paper into tiny pieces at once. What a beautiful mess. And the arrows still worked. Yeah, I don't know. Maybe I was trying to make too many assumptions here. Probably. Or too many... I was trying to make it harder than it was supposed to be. I guess here. Yeah. I don't know. Sometimes you make things harder for yourself than you should be, right? Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.